Question number 5. Discuss the importance of dimensionality reduction in machine learning. Compare and contrast feature extraction and feature selection as two approaches to dimensionality reduction and provide examples of technique used for each approach. So first, let's see what is dimensionality reduction. So when working with machine learning model datasets with too many features can cause issues like slow computation and overfitting. Dimensionality reduction helps to reduce the number of features while retaining key information. It converts high dimensional data into a lower dimensional space while preserving important details. So reduction means reducing the numbers of features in a dataset while keeping the important information intact. For example, if your dataset has hundreds of columns, not all of them matters, but some are useless and some are duplicates and some add noise. So by reducing dimensions, our model becomes faster, less prone to overfitting, and easier to visualize and more efficient to work on. So how dimensionality works? So let's understand dimensionality with the diagram. So imagine data points. So let's see. Let's understand how dimensionality reduction is used with the help of example. Imagine a data set where each data point exists in a 3D space defined by axes x and y and z. The three-dimensional as x, y, and z axis. So if most of the data variance occurs along x, y, and then z dimension, may contribute very little to understanding the structure of the data. So imagine data points plotted in 3D space with x, y axis. But suppose most of the pattern or variance is along x and y. So this means that z dimension is not adding much information. So instead of working in 3D, we can project the data onto 2D, keeping x and y only. This reduces noise and improves training speed and keeps all the important information intact. That's basically reduction. That's how reduction works. Now moving on to the another example, which is in tabular form. There are four sections: students, their height, their weight, and BMI. So student A has height 170 in centimeters, and weight 65, and BMI 22.5. So explaining the table point wise, the data set has three features: height, weight, and BMI. And BMI is not an independent feature because it is calculated from height and weight. So BMI does not add new information and becomes a redundant feature. So therefore important information exists only in two dimensional height and weight. So we will keep both of them and we will exclude BMI so that our data be concise and precise and without no noise. So the dimension from 3 is changed to 2 without losing any knowledge. So why do we reduce dimension? We reduce dimension to remove unnecessary features. So the model becomes simpler, faster, and without losing important patterns in the data. So by reducing the model from 3D to 2D features, here we keep core information while improving the model performance. So as explained in the notes, dimensionality reduction helps with faster training and lower storage requirement, less overfitting, better generalization, improved visualizations, and simpler and more interpretable models. And now let's move on to the dimensionality reduction techniques. So the first is feature selection. The feature selection is important feature from the existing data set. It does not change data, it chooses the best column and it chooses the best column. So in this we have filter method. The graph explanation of this is let's explain the diagram. At the top you see several green dots, green circles. Each circle represents a feature. Step 1, there is a ranking feature by statistical course. The method ranks all features based upon the statistical tests like uh, chi-square and correlation or mutual information. So now the second step is select top ranked features. Only the highest ranked feature are chosen. This is shown in the diagram where only a few circles move downwards. Then the third step is feed into model. This selected feature go directly into the model, so the graph visually shows features being filtered based on the ranking. You can see first we have the model's ranks, then we have to number them. The highest rank feature are chosen and the other are there only, and then third step we move the higher ranks and hence our data is reduced. Second is wrap method. So here's the let's see the graph. Here we have select a subset of feature, train model and evaluate, repeated a different subset. So the first step, select a subset. The method tries a combination of features, not all at once. And in the train and evaluate, the model is trained using that set. This is shown by the diamond shaped model. Here there is a written model, and then train and evaluate. The model is trained using that set, and this is shown by the diamond shaped model box. Then repeat, different subsets are tried again and again and again and again, and which subsets give the best model accuracy wins. So the graph is illustrating the trial and errors loop. Third, the embedded method. The embedded method is no special graph as shown here, but conceptually the model itself decided which feature matter most. Basically, the graph decided itself which feature matters most. Moving on to the feature extraction. Feature extraction is the process of transforming raw data into simplified and informative sets of features or attributes. This reduces data complexity and highlights the most relevant information, making it easier for machine learning tools or models to analyze and learn from the data efficiently. It plays an important role in improving model accuracy and reducing computational costs by focusing on essential aspects of the data. Some methods are statistical methods, dimensional reduction, backward feature elimination, etc. So, the feature extraction transforms data into a new space. Unlike feature selection, it creates new features. Popular techniques includes PCA, LDA, autoencoders, and kernel PCA. This methods compress the data but keep the maximum variance. Imagine taking many features and squashing them into new access that capture the most information. That's what features extraction graph usually show. Data being rotated and projected into fewer dimensions. This is called feature extraction. So sorry. Okay. So different feature selection and feature extraction methods are in the feature selection. It chooses a subset of existing features. It keeps original meaning and uses filter, wrapper, embedded methods. It needs domain knowledge and it is easy to interpret, but may remove useful info if not careful. In feature extraction, it creates a new transform features, changes data representation, uses PCA, LD, and autoencoders, and works on raw data. It handles complex patterns, and but many creates features that are hard to interpret. So this was all the different features between our feature selection and feature extraction methods. So this is all for today. We have completed the question number 5 also and the required answers of the questions asked. We have explained the importance of damage reduction in machine learning. We have compared the contrast feature between the feature extraction and feature selection and two approaches, and we have also covered the two approaches of dimensionality reduction and provided example for the techniques used for each approach. So thank you so much. In the next video, we will cover the question number 6. Thank you.